So I'd like to revise with you a few different methods we have for plotting graphs. Specifically today we'll concentrate on straight line graphs. What I'm going to do is draw the same graph but a few different ways. I don't know what method you learnt last year, but I'd just like to revise a few of the different methods that teachers often use. So the graph we're going to plot initially has equation y equals 3x minus 2. The first way we're going to think about this is as a little function machine. You can think of this as when you input the number x, what comes out is the number y. So it's like a little function machine. You put a number in and out comes another number. For example, if I were to choose my input x to be 10, 3 times 10 is 30, take away 2 gives me 28, so my output would be 28 if I put x equals 10 into the function machine. Okay, so I'm just going to choose a few random ones. For example, if I chose, I'm always going to choose them as choose an input and get an output, and I'm going to write the answer as a coordinate. You always have coordinates being the x first, input first, and then the y, the output second. So suppose I choose the number 1, let's say. Well, 3 times 1 is 3, take away 2 is 1. So if x is 1, then y is 1. 3 times 1, take 2, is also 1. That's a coordinate. I can plot that on the graph. 1, 1 is there. Okay, that's not the only one that's on there. I could have chosen another coordinate. How about if I choose input 2? Okay, 3 times 2 is 6. Take off 2 is 4. So if the input, if x is 2, the output is the y is 4. 2, 4 is also on the graph. There it is. Okay. How about minus 1? Okay, got to be good with your negative numbers here. What if I choose x to be minus 1? Well, 3 lots of minus 1 is minus 3. Take away another 2, takes me all the way down to minus 5. That is also on the graph. Okay, so minus 1, minus 5 is all the way down here. Now you finish the graph off by just connecting these dots together, like so. You might notice that when I plotted the graph, the actual line part of the graph, I didn't just stop at the coordinates. In fact, this line is infinitely long, so it must fill the whole scene basically. My graph goes as high as 8 and as low as minus 8 as the output, so it fills the whole scene. Okay, you always extend the line to be as large as it can be in the area given. Okay, another way teachers often do this is by getting you to construct what's called a little table of values. So you might have a table that has x and y, let's say. And you can choose whatever numbers you like for x, how about 0, 1, 2, 3, etc. Up to you. And then do as we did before, but rather than just randomly choosing numbers, we're being a bit more structured about it. But it's basically the same idea. So if x is 0, 3 times 0 is still 0, take off 2 is minus 2. And we already know these. 3 lots of 1 take 2 gave us 1. 3 lots of 2 take 2 gave us 4. We didn't do this one. 3 times 3, if I put the 3 in here, 3 times 3 is 9, take off 2 gives me 7. So 3, 7 is on there. So it's much the same as before. I will plot these points, so 0, minus 2, 1, 1. It might be less clear in the table that these are still coordinates, but they are still coordinates exactly the same as the first method. So I'll finish plotting these and connect it up with a line for you. And you'll notice that the answer is exactly the same as before. So our method really here is to either make up some random inputs for x and then see what comes out for y, or be a bit more structured about it, have a list of inputs that we want. We can still make those up. Any inputs will do, and then to see what comes out. And you can put it in a little table to be a bit more structured about it. The next method I'm going to show you makes use of a Casio calculator. Now, my calculator is the most recent one, which is the ClassWiz. If you have the edition before, it will be very similar, but might not look exactly the same as what I have on my screen here. So I'm going to start by doing mode, I think it says mode on old calculators, it says menu on mine, and I'm looking for table mode. Typically that's mode 3 or 4 on the old calculators, but I'm looking for table mode, and on here that's number 9. So if you have the class whiz, it's number 9, and it comes up like this: f of x equals. Okay, what I'd now like to type in is 3x minus 2. So 3 is easy. It's just off the edge, but I've just typed 3, obviously. To get x, that's here. That's above the close bracket button, and it's in pink. To get pink things, you press the alpha button first. So alpha and close bracket comes up with the x. I wanted 3x take away 2. You can't see off the edge now, but I'm going to press equals. That might not come up on your calculator. If you have the old edition, it won't ask for a second function, but I only want to plot one graph at a time. I don't need a second function. I just want to do 3x minus 2. So we'll ignore that and press equals. It says, where would you like to start? Well, my graph starts over at minus 6. So when it says start, that's where does your x-axis start? Okay, my x-axis starts at minus 6. Now, you might not realise, but actually this is the button for a negative number. The button that's down on the bottom right is for subtraction. This is for negative numbers. So if I want to type minus 6 in, I should really type minus 6 like this, equals. And it finishes up at positive 6, so positive 6 equals, and step size of 1 is ideal. This is going up in 1s, isn't it? It goes from 1 to 2 to 3 to 4. It doesn't jump up in 2s or anything, it jumps up in 1s. That's what it means by step size. So I press equals, and what it's given me is a table. It's actually given me all the coordinates. Not all of these will fit. So what this is actually telling me is the coordinate minus 6 minus 20 would be on the graph. So minus 6, I've got to go all the way down to minus 20, that goes off the edge. Okay, so I can't plot that one. In fact, the first one I can plot, go down, 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 even that goes off the edge, minus 11, but I can plot this one, minus 2, minus 8, that's on there, isn't it? Minus 2, minus 8, just about fits on, that's there. Okay, go down. This is one we did before. We calculated this one manually. Minus 1, minus 5 is on there. That one's not so much of a surprise. Okay, 0, minus 2, we did at some stage. So these are just giving us coordinates. It says f of x, but that's the same as meaning y. Okay, f of x, y, output, all mean the same thing. So 1, 1 is on there. 2, 4 is on there. And 3, 7 is on there. There are some more. In fact, it tells me the other numbers, but they don't fit on. So 4, 10 goes off the edge. Only just, like I put it on there, but it does go just off the edge, doesn't it? So what's that? 8, 9, 10 goes just off the edge. This one's really off the edge, 5, 13. I'm not going to be able to fit that one on there. Okay, so like before, I'm now going to connect those points with a line. And so for the third time now, we have the same graph. Okay, so method 1 was choose any number we like as an input, and then we use the equation to figure out the output. This is just coordinates. This is the same method, most often the one that teachers use, making a little table. And this one was also making a little table, but doing it on the calculator. There's a special mode called table mode, which will work out the coordinates for you. Now finally, my last method, and the one that I like the most advanced one, it turns out that these numbers in the equation actually have a specific meaning, and we can use just these two numbers. They're the only two numbers we need to plot the whole thing. So the minus 2 actually tells us whereabouts the graph goes on the y-axis. We call it the y-intercept. So minus 2 is down here on the y-axis. So I know the graph will go through there. And the 3, its proper name is gradient, but that basically means steepness, how steep the graph is. So 3 specifically means every time we go along 1 square, we need to go up 3. So if it's along 1, it's up 1, 2, 3. Along 1, up 1, 2, 3. Along 1, up 1, 2, 3. I can go backwards as well, so we know it starts at minus 2 on the y-axis. If I go left by 3, sorry, if I go left by 1, then it's going to go down by 3, isn't it? Okay, to keep that pattern carrying on. So very quickly I can get lots of coordinates easily, and once again I'll connect those points together. And we end up with the same answer as before. It's the same equation, so I hope we get the same answer as before. So that method was this number here called the y-intercept. It tells you where it crosses the y-axis, so you can start there. And then this number, its proper name is gradient, tells you how steep the graph is, and that is every time you go one to the right, it's how many squares up you have to go. Now I say how many squares up you have to go, actually you need to be careful, it's how many units on the scale. And what I mean by that, I'd like to plot the same graph yet again, but just on different axes. So very often axes are given to you in the question. You don't get a choice about what they look like. So for this question, I still want to plot y equals 3x minus 2, but I want to do it on this set of axes, which has already been designed for us. And I'm going to use this method. I could use any of them, but I will use this method. That's where you say, okay, we start at minus 2 on the y-axis. So far, so easy. But please watch this really carefully. Every time I go along 1, I've got to go up 3. But on the scale, that is 1. It's 2 squares, but it's 1 unit. And this is up 1, 2, 3. Okay, you could have completely bizarre scales in both directions. As it turns out, the y-axis is pretty well behaved. It's just 1 square is 1 unit. But in the x direction, that is 1 unit, isn't it? Okay, you need 2 squares to represent 1 unit. So just be careful with that. So same again, along 1 up 3, along 1 up 3. So it's along 1 unit up 3 units. Okay, this time I can fit an extra 1 on there. I can get 4, 10 on there this time, can't I? Which I couldn't before. Along 1 down 3, along 1 down 3. I won't quite fit another 1 on this time because I may as well do it. It goes to minus 11, doesn't it? But it's just slightly off the edge this time. Okay, and once again, I will connect that up for you. And once again, that's the same answer. So what I've shown you there then is how to plot straight line graph. Okay, you sort of need to know about each way of doing it because it could arise from, the question could be phrased in different ways. So you do need to kind of understand each different way. If you're given a free choice, then do any method you like. That's up to you. So to recap, method number 1 was where we just pick a number for the input, the x-coordinate, and then just see what happens to the output, the y-coordinate, and then plot the coordinates. Method 2 was design a little table. The x's could be anything. Sometimes the question already has some x's filled in, and you just fill in some blank y's, and then you plot those on there. These are just coordinates once again. This method here was where we did table mode on the calculator. Okay, so we did menu or mode, chose table mode, it came up with f of x, and we typed in x by doing alpha and the close bracket button. And this method here, lastly, was where we said that's where you cross the y-axis, but that's the steepness, the gradient. Y-intercept, gradient. So you can start there on the y-axis. Every time it goes along 1, it's going to go up by 3. Okay, and that's how you draw straight line graphs.